Hello everyone, today we'll study polar coordinates. We know that in general, in the xy plane, we use a pair of x and y to represent points. In the plane. And here, the point x and y is called the Cartesian coordinates. The other pair x and y is called the Cartesian coordinate. In polar coordinate, it's very similar. In polar coordinate, we use a pair of r and theta. In polar coordinate, we use a pair of r and theta to represent points in the xy plane. In polar coordinates, we use a pair of r and theta to represent points in the xy plane. Now, what does r and theta means? What does r and theta means? Let me show you an example. Let P be a point in the xy plane. Assume its polar coordinate is r and theta. Let point O be the origin in the xy plane. Let O be the origin in the xy plane. Let me show you the picture here. Assume that's the xy plane. This is the x-axis. This is the y-axis. P is a point on the xy plane. Origin is point O. R represent the R coordinate of point P represent distance from origin to P. R represent distance from origin to P. That's an R coordinate of point P. That's an R coordinate of point P. R represents the distance from origin to point P. R represents distance from origin to point P. That's an R coordinate of point P. How about the theta? Once I connect the point OP, I have a line segment here. Theta represents the angle from the positive x-axis to the line segment OP. Theta represents the angle from the positive x-axis to the line segment OP. And this angle must be in radian measure. This angle theta must be in radian measure. So angle theta is in a radian measure. Of an angle from the positive x-axis to the line segment OP. And r and theta together is called a polar coordinate of point P. R and theta together, they are called a polar coordinate of point P. Next, let me show you some example about polar coordinates. Plot each of the following polar points in the xy plane. Plot each of the following polar points in the xy plane. Part A, the point 2, pi over 3. If this point is given as polar point, the first number represents r, second number represents theta. R represents distance from the point to the origin. Distance from the origin to the point is 2. Distance from the origin to the point is 2. And the angle between the line segment and positive x-axis is pi over 3. When we plot polar point, usually plot angle first, graph angle first. Theta is pi over 3, so start from positive x-axis. Pi over 3 is 60 degrees, somewhere here. Start from positive x-axis. Pi over 3 is about 60 degrees, somewhere here. This is pi over 3. R is 2, so we move 2 units away from the origin. R is 2. We count 2 units from origin. Say 1, 2. Count 2 units from origin. That's the polar point. 2, pi over 3. That's the polar point. 2, pi over 3. Next. 3, 5 pi over 4. If this point is given as polar point, 3 is the r coordinate, and theta is 5 pi over 4. If this point is given as polar point, first number represents r, second number represents theta. Then plot this point in the xy plane. Usually we draw angle theta first. Angle theta is an angle start from positive x-axis, rotate counterclockwise by 5 pi over 4. So angle theta start from positive x-axis, rotate counterclockwise by 5 pi over 4. 5 pi over 4 is a little more than 1 pi. Pi is here. 5 pi over 4 somewhere here. That's an angle 5 pi over 4. Start from positive x-axis. Theta is 3. Theta is 3. So start from origin, measure 3 units. Start from origin, measure 3 units. 1, 2, 3. That's the polar coordinate. 3, 5 pi over 4. That's the polar coordinate. 3, 5 pi over 4. Next. 1, negative pi over 6. 1, negative pi over 6. So if that's a polar point, first number represents r, second number represents theta. In the xy plane, we usually draw angle theta first. Theta is an angle start from positive x-axis. When the angle is positive, we measure the angle counterclockwise. But when the angle is negative, go in the opposite direction. When the theta is negative, go opposite direction. So we measure the angle clockwise. Negative pi over 6, somewhere here. That's an angle negative pi over 6. That's an angle negative pi over 6. R is 1. So we measure 1 unit, start from origin. Measure 1 unit, start from origin. We measure 1 unit, start from origin. So this point is the polar coordinate, is the polar point 1 comma negative pi over 6. That's the polar point 1 comma negative pi over 6. Next, 2 comma negative 7 pi over 6. 2 comma negative 7 pi over 6. First number represents r. Second number represents theta. Negative 7 pi over 6. Plot a point in the xy plane. Usually draw the angle first. Angle is negative 7 pi over 6. Since theta is negative, we measure the angle clockwise. 7 pi over 6, that's a little more than 1 pi. 7 pi over 6 somewhere here. So this is the angle negative 7 pi over 6. R is 2. So we measure 2 units, start from origin. 1 unit, 2 unit. Measure 2 units, start from origin. That's the polar point 2 comma negative 7 pi over 6. Next, plot the polar point negative 1 comma 11 pi over 4. Plot the polar point negative 1 comma 11 pi over 4. First number negative 1 represents r. Second number 11 pi over 4 represents theta. In the xy plane, let's measure angle theta first. In the xy plane, let's measure angle theta first. What's 11 pi over 4? 11 pi over 4 is more than 1 cycle. 11 pi over 4 is more than 1 cycle. 11 pi over 4 minus 2 pi is 3 pi over 4. That's the coterminal angle of 11 pi over 4. That's the coterminal angle of 11 pi over 4. So theta is 11 pi over 4. The coterminal angle is 3 pi over 4. Let's measure 3 pi over 4. Start from positive x-axis. 3 pi over 4 somewhere here. That's the coterminal angle of 11 pi over 4. That's the coterminal angle of 11 pi over 4. So that's an angle 11 pi over 4. R is negative 1. We know when r is positive 1, we go this way out. When r is positive 1, positive 2, positive 3, we go this way out. But here r is negative 1. So we measure in the opposite direction. When r is negative 1, we measure in the opposite direction. When r is positive 1, positive 2, positive 3, we measure in this direction. But when r is negative 1, we measure in the opposite direction. That's an opposite direction. That's negative 1 unit from the opposite direction. So that's the polar point, negative 1 comma 11 pi over 4. Theta equal 11 pi over 4 is this direction. Let's consider the positive direction when theta is 11 pi over 4. This is considered a positive direction when theta is 11 pi over 4. So when r is negative 1, we measure in the opposite direction. We move to the opposite direction. That's negative 1 comma 11 pi over 4. This is a polar point of negative 1 comma 11 pi over 4. Next, plot the polar point negative 2 comma 7 pi over 2. Again, 7 pi over 2 is more than 1 cycle. We need to find a coterminal angle. 7 pi over 2 is more than 1 cycle. We need to find a coterminal angle for 7 pi over 2, which is, take 7 pi over 2 minus 2 pi, I get 3 pi over 2. That's the coterminal angle of 7 pi over 2. In the xy plane, when theta is 3 pi over 2, we are here. Pi over 2, pi, 3 pi over 2. When theta is 3 pi over 2, that's the direction. When theta is 3 pi over 2, that's the direction of angle theta. Then r is negative 2. Since we consider this as positive direction, When r is -2, we measure in the opposite direction. So -1, -2. That's the polar point, -2, comma 7 pi over 2. Here, be very, very careful. When theta is 7 pi over 2, we consider this direction is the positive direction. When theta is 7 pi over 2, angle is here. We consider this direction as a positive direction. When r is -2, we measure in the opposite direction. This direction r is +1, +2, +3, and so on. The opposite direction, in the opposite direction, r is -1, -2. Next, plot the polar point -2, comma 4 pi over 3. -2, comma 4 pi over 3. Here, angle theta is 4 pi over 3. Let's measure angle theta first. Let's measure angle theta first. Theta is 4 pi over 3. 4 pi over 3 is a little more than pi. Somewhere here. When theta is 4 pi over 3, that's the direction. That's the positive direction. This is angle 4 pi over 3. We consider this as positive direction. Then here r is -2, so we need to point to the opposite direction. In this direction, r is 1, 2, 3. Here r is -2, so you need to measure the angle in the opposite direction. Measure r in the opposite direction. That's 1 unit, 2 unit. That's where r is -2. That's where r is -2. So that's the polar point -2, comma 4 pi over 3. That's the polar point -2, comma 4 pi over 3. Next, 2, comma -5 pi over 3. 2, comma -5 pi over 3. So let's measure angle theta first. Let's measure angle theta first. When theta is -5 pi over 3, -5 pi over 3, we rotate counterclockwise, it's somewhere here. If we measure angle counterclockwise, so if we measure angle clockwise, that's theta equal to -5 pi over 3. Theta is -5 pi over 3. So we consider in this direction, r is positive. In this direction, r is positive. And r is 2 here. We have 1 unit, 2 unit. That's the polar point 2, comma -5 pi over 3. That's the polar point 2, comma -5 pi over 3. Now if we observe these points here, we can see that point G and H, they are exactly the same points in the SY plane. Point G and H, they have different polar coordinates, but they're exactly the same point in the SY plane. The same as part A. Part A also have the same position as part G and part H, but they have different polar coordinates. So keep this in mind. When we use polar coordinates, every point in the SY plane has more than one representation, or you can say has multiple representation. Every point in the SY plane has multiple representations. Keep this idea in mind. Next, I'll show the conversion between the Cartesian coordinates and polar coordinates. Next, I'll show the conversion between the Cartesian coordinates and polar coordinates. Next, I'll show you the conversion between the Cartesian coordinates and polar coordinates. Let me show you the picture again. Suppose R is a point in the xy plane. What's its x coordinate? What's its x coordinate? X coordinate is a distance from the point to the y-axis. It's called x coordinate. Distance from the point to the y-axis is called x coordinate. So distance from the y-axis to the point. Distance from the y-axis to point P is called s coordinate. The y coordinate is the distance from the x-axis to point P. That's called y coordinate. Distance from x-axis to point P, that's called a y coordinate. Theta, r is a distance from origin to point P. R is a distance from origin to point P. This is r. R is a distance from the origin to point P. Theta is the angle between the line segment OP and the positive x-axis. So angle theta is the angle from positive x-axis to the line segment OP. So that's S, Y, that's R, it's theta. How do they relate it to each other? How do they relate it to each other? How do they relate it? If you observe this picture here, you can see that this is a right triangle. If you observe this picture, you can see that this is a right triangle. So we have x squared plus y squared equal to r squared. That's in the first relationship. Next, if we try to use trig identities, refer to angle theta, that's an opposite side, that's a hypotenuse, that's opposite, that's hypotenuse. So I can say sine theta equal to y over r. Sine theta equal to y over r. If I solve this equation for y, I can write y equal to r sine theta. Another trig identity is, in this right triangle here, refer to angle theta. This is adjacent, this is hypotenuse. X is adjacent, r is hypotenuse. So I can say cosine theta equal to x over r, adjacent over hypotenuse. If I solve this equation for x, I can write x as r cosine theta. I can write x as r cosine theta. Then if I use tension, refer to this angle, y is the opposite, x is adjacent. So I can say tension theta is y over x. Tension theta is y over x. So keep these four formulas in mind. X squared plus y squared equal to r squared. Tension theta equal to y over x. Y equal to r sine theta. Usually write x first. S equal to r cosine theta. Write x first. S equal to r cosine theta. Y equal to r sine theta. Memorize these four formulas. We will use these four formulas to convert the coordinates between Cartesian coordinates and polar coordinates. And in general, if we try to convert from Cartesian coordinates to polar coordinates, we use these two formulas. When we try to convert from polar coordinates to Cartesian coordinates, we use these two formulas. So from Cartesian coordinates to polar coordinates, we use these two formulas. From polar coordinates to Cartesian coordinates, we use these two formulas. In general, this way is easier. Converting from polar coordinates to Cartesian coordinates is easier. Going backward is harder. From Cartesian to polar is harder. Let me show you the simple part first. Let me show you the easier part first. Look at a simple example. Look at some simple example here. Let's do the simple, easier part first. Convert each of the following points from polar coordinates to Cartesian coordinates. from polar coordinate to Cartesian coordinate. Part A. 3 comma pi over 6. If this point is given as a polar point, 3 represents r. Pi over 6 represents theta. If we try to convert from polar coordinate to Cartesian coordinate, that means we try to find x and y. If we try to convert from polar coordinate to Cartesian coordinate, that means we try to find x and y. So the formula for x and y is x equal to r cosine theta, y equal to r sine theta. So s equal to r cosine theta, which is 3 times cosine pi over 6. Cosine pi over 6 is radical 3 over 2. So the answer is 3 radical 3 over 2. Y is r sine theta. That's 3 times sine pi over 6. R is 3, theta is pi over 6. Sine pi over 6 is half. 3 times half is 3 half. So the Cartesian coordinate for this point, the Cartesian coordinate is 3 radical 3 over 2, comma 3 over 2. That's the Cartesian coordinate of this point. That's the Cartesian coordinate of this point. Next, 2 comma 2 pi over 3. We try to convert the polar coordinate to Cartesian coordinates. If we consider this is a polar coordinate, then the first angle represents r. Second number represents theta. Theta is 2 pi over 3. S is r cosine theta, which is 2 times cosine 2 pi over 3. How do we find cosine 2 pi over 3? Here, let me review the reference angle for you. The reference angle of angle theta is the acute angle from the passive s-axis, from s-axis, from the entire s-axis, from s-axis to the terminal side of angle theta. Usually we use x bar we use theta bar to represent the reference angle. Usually we use theta bar to represent the reference angle of angle theta. Usually use theta bar to represent the reference angle of angle theta. Now let me show you a picture. Let theta be an angle from 0 to 2 pi. Let theta be an angle from 0 to 2 pi. Then there are 4 cases. Theta is either in the first quadrant, second quadrant, third quadrant, or the fourth quadrant. Let me discuss each case individually. If theta is in the first quadrant, then that's the terminal side. That's the terminal side of angle theta. Reference angle is the angle from, is the acute angle from s-axis to the terminal side. So this is the reference angle. If angle theta terminates in quadrant 1, then this is the reference angle. So in quadrant 1, the reference angle is the same as angle theta. in quadrant 1, reference angle is the same as angle theta. Now, if angle theta terminates in quadrant 2, reference angle is the cube angle from s-axis to the terminal side of the angle. If this is angle theta, this side is considered the terminal side of angle theta. So that's a reference angle. Reference angle is the angle from s-axis to the terminal side of angle theta. So in quadrant 2, how do we find a reference angle? How do we find a reference angle in quadrant 2? We know 0 is here, pi over 2 is here, pi is here. Reference angle here is angle between pi and theta. Here, reference angle is an angle between pi and theta, which is pi minus theta. Reference angle is an angle between pi and theta, so that's pi minus theta. Use larger minus smaller, larger number minus smaller. Reference angle is always between 0 and 90 degrees, it's always positive. Use pi minus theta, that's a reference angle in quadrant 2. How about in quadrant 3? Or if theta terminates in quadrant 3, then that's the terminal side. That's the terminal side of angle theta. Reference angle is an angle between s-axis and the terminal side of angle theta. So here, that's the reference angle in quadrant 3. This is a reference angle in quadrant 3. How do we find reference angle here? We know this side is pi. Reference angle is an angle between pi and theta. And theta here is larger than pi. In quadrant 3, theta is larger than pi. To make it positive, in order to make a reference angle positive, we use theta minus pi. That's how we find reference angle if the angle terminates in quadrant 3. Now, what if the angle terminates in quadrant 4? What if the angle terminates in quadrant 4? Then angle theta is here. Reference angle is an angle between s-axis to the terminal side of the angle. So this is a reference angle. Reference angle is angle from s-axis to the terminal side of angle theta. Then how do we find angle theta here? We know this side, if we complete one cycle, it goes back to 2 pi here. If we complete one cycle, it goes back to 2 pi here. The angle is 2 pi. If we complete one cycle, this angle is 2 pi. So for angle theta, we can use 2 pi minus theta. We try to make the reference angle positive, so use 2 pi minus theta. We try to make the reference angle positive, so use 2 pi minus theta. That's the reference angle in quadrant 4. Now, this angle, 2 pi over 3, this angle terminates in which quadrant? 2 pi over 3 is a little less than pi. So this angle terminates in quadrant 2. For angle in quadrant 2, for the reference angle in quadrant 2, we use pi minus the actual angle, which is pi over 3. So the reference angle for 2 pi over 3 is pi over 3. Cosine function in quadrant 2 is negative. Cosine function in quadrant 2 is negative. Cosine is positive in quadrant 1 and quadrant 4, negative in quadrant 2 and quadrant 3. Cosine function in quadrant 2 is negative. Cosine pi over 3 is half. So you get 2 times half. 2 times negative half, which is negative 1. For the y coordinate, the formula is r sine theta. I get 2 times sine 2 pi over 3. Same thing for 2 pi over 3, its reference angle is pi over 3. Sine function in quadrant 2 is positive. Sine function in quadrant 2 is positive. Then sine pi over 3 is radical 3 over 2. Multiply together, we get radical 3. So the Cartesian coordinate for 2 comma 2 pi over 3 is -1 comma radical 3. That's the Cartesian coordinate for 2 comma 2 pi over 3. Next, -4 comma 4 pi over 3. -4 comma 4 pi over 3. If that's a Cartesian coordinate, if this is a polar coordinate, then r equal to -4, theta equal to 4 pi over 3. We find x and y coordinates. X is r cosine theta, which is -4 times cosine 4 pi over 3. 4 pi over 3 is in quadrant 3. 4 pi over 3 is in quadrant 3. Cosine function in quadrant 3 is negative. And what's the reference angle here? 4 pi over 3 terminates in quadrant 3. 4 pi over 3 terminates in quadrant 3. So for angle in quadrant 3, the reference angle is the angle itself minus pi. To find a reference angle for angle in quadrant 3, we use an actual angle, angle itself minus pi, which is pi over 3. So reference angle is pi over 3. And cosine function in quadrant 3 is negative. Cosine pi over 3 is a half. -4 times -half is +2. That's the s coordinate. For the y coordinate, y equal to r sine theta, which is -4 times sine 4 pi over 3. And 4 pi over 3 terminates in quadrant 3. The angle 4 pi over 3 terminates in quadrant 3. Sine function in quadrant 3 is negative. For 4 pi over 3, the reference angle is pi over 3. So I get -4 times negative sine pi over 3 is radical 3 over 2. So I get -2, +2. Double negative is positive. I get +2 radical 3. So the Cartesian coordinate for this point is 2 comma 2 radical 3. That's a Cartesian coordinate for this point. Next, -2 comma -pi over 3. Convert from polar coordinates to Cartesian coordinates. If we consider this is a polar coordinate, then r is -2, theta is -pi over 3. We try to find the s and y coordinates. S is r cosine theta, which is -2 times cosine -pi over 3. How to find a reference angle here? How to find reference angle for cosine -pi over 3? -pi over 3 is somewhere here in quadrant 4. This is angle -pi over 3. The reference angle is the angle between, it's the cube angle between s-axis and the terminal side of this angle. And this angle here is pi over 3. So we can use pi over 3 as a reference angle. Reference angle is the angle between the s-axis and the terminal side of the angle. And since this angle is -pi over 3, The Q angle here should be pi over 3. So that's a reference angle. And cosine function in quadrant 4 is positive. If I use reference angle, cosine function in quadrant 4 is positive. Then we have negative 2 times cosine pi over 3. Cosine pi over 3 is half. Negative 2 times half is negative 1. For the y coordinate, we use r sine theta. R is negative 2. Sine is negative pi over 3. Sine function in quadrant 4 is negative because negative pi over 3 terminates in quadrant 4. Sine function in quadrant 4 is negative. So you get negative sine pi over 3 here. Sine pi over 3 is radical 3 over 2. Multiply out, we get positive. Double negative is positive. We get positive radical 3. So the Cartesian coordinate for this point is negative 1 comma radical 3. There's a Cartesian coordinate for this point. Next, convert each of the following points from Cartesian coordinates to polar coordinates. This two is harder. Going backward is harder. From Cartesian to polar is harder. Here we use the formula x squared plus y squared equal to r squared, and tangent theta equal to y over x. When we try to convert from Cartesian coordinate to polar coordinate, we use these two formulas to find r and theta. First example, the point 2, 1. If this is Cartesian coordinate, then x represents 2, 2 represents x, 1 represents y. X is 2, y is 1. 2 represents x, y represents 1. We try to find r and theta. So we can use the first formula to find r. R squared equal to x squared plus y squared, which is 2 squared plus 1 squared. 2 squared plus 1 squared is 5. So r squared equal to 5. That means r equal to what? If r squared is 5, what's r? In general, r could be plus or minus vertical 5. In general, r could be plus or minus 5. Plus minus vertical 5. But to make our life easier, we try to choose r to be positive vertical 5. In general, to make our life easier, we choose r to be vertical 5. In general, to make our life easier when doing conversion, we choose r to be positive. Make theta between 0 and 2 pi. In general, when we try to convert from Cartesian coordinates to polar coordinate, to make our life easier, choose r to be positive and choose theta to be between 0 and 2 pi. Since I'm choosing r to be positive, r is vertical 5. Then how do we find theta? We use the second formula to find theta. Second formula says tangent theta is y over x. Tangent theta is y over x. That means tangent theta, if I plug in y over x, I get 1 over 2. Now here, we need to find a reference angle first. We cannot find an angle directly. We need to find a reference angle first. Reference angle is inverse tangent of 1 over 2. Reference angle is inverse tangent of 1 over 2. and this is not special, and this is not special value. We leave it the way it is. Angle theta, reference angle, is inverse tangent of 1 over 2. This is not special value. We leave it the way it is. Now, once I know reference angle, we try to find angle theta based on its reference angle. How do we find angle theta based on its reference angle? If the angle terminates in quadrant 1, theta bar equal to theta, which means theta equal to theta bar. If theta bar equal to theta, means theta equal to theta bar. In quadrant 2, if the angle terminates in quadrant 2, theta bar equal to pi minus theta. If I try to solve this equation for theta, theta is pi plus theta bar. If I try to solve this angle for theta, theta is pi minus theta bar. If I try to solve this angle for this equation for theta equal to pi minus theta bar. If theta terminates in quadrant 3, theta bar is theta minus pi. If I try to solve this equation for theta is pi plus theta bar. If I try to solve this equation for theta is pi plus theta bar. And if an angle terminates in quadrant 4, theta bar is 2 pi minus theta. Then theta here can be written as 2 pi minus theta bar. Theta can be written as 2 pi minus theta bar. So that's how we find theta using the reference angle. And here, theta must be between 0 and 2 pi. Theta must be between 0 and 2 pi. We can use this formula to find theta based on its reference angle. When theta is between 0 and 2 pi, we can use this formula to find theta based on its reference angle. Now, next, in order to find theta, we need to decide the quadrant. Which quadrant does this point locate? Let's design the quadrant here. Which quadrant does this point locate? 2, 1. Since S is positive, Y is positive. This point located in quadrant 1. Since S is positive, Y is positive. This point located in quadrant 1. Since theta located in quadrant 1. Since theta located in quadrant 1. In quadrant 1, theta is the same as its reference angle, which is inverse tangent of a half. In quadrant 1, theta is the same as its reference angle. So theta is inverse tan of 1 over 2. So the polar coordinate here is vertical 5, comma, inverse tangent of 1 over 2. That's the polar coordinate for this point, for this Cartesian point. Part B. -3, -3. If this is a Cartesian point, then x is -3, y is also -3. First number represents x, second number represents y. We try to find r and theta. We know that r squared is s squared plus y squared, which is -3 squared plus -3 squared. -3 squared is 9. 9 plus 9 is 18. To make it easier, we take r to be radical 18. Radical 18 can be rewritten as 3 radical 2. That's r. Next, try to find theta. Using the formula, tangent theta equal to y over x. That means tangent theta equal to -3 over -3 is 1. Then for the reference angle is inverse tangent of 1. Inverse tangent of 1, that's a special value, that's pi over 4. So the reference angle is pi over 4. Next, we try to find the actual angle. First of all, let's design a quadrant. Which quadrant does this point locate? S is -3, y is -3. Since both s and y are negative, this point located in quadrant 3. So we know angle theta terminates in quadrant 3. angle theta terminates in quadrant 3. Then we try to find angle theta based on its reference angle. In quadrant 3, angle theta is pi plus its reference angle. For angle in quadrant 3, the actual angle theta is pi plus the reference angle, which is pi plus pi over 4. Pi plus pi over 4 is 5 pi over 4. So angle theta is 5 pi over 4. R is 3 radical 2. Theta is 5 pi over 4. Next, 3, negative 1. Convert from Cartesian coordinate to polar coordinates. So if that's a Cartesian coordinate, we have s equal to 3, y equal to negative 1. We try to find r and theta. We know that r squared is s squared plus y squared, which is 3 squared plus negative 1 squared. 3 squared is 9. 9 plus 1 is 10. Take square root, r equal to square root of 10. Then find theta. We know the tangent theta is y over x. Y over x is negative 1 over 3. Next, find a reference angle. For reference angle, we must drop negative sign, take absolute value. For reference angle, we must take absolute value, drop negative sign. Inverse tangent of 1/3. Because reference angle is always positive. So we must drop negative sign, take absolute value, drop negative sign. So reference angle is inverse tangent of 1/3. This is not special value, we leave it the way it is. Inverse tangent of 1/3 is not a special value, we leave it the way it is. Next, based on the reference angle, find the actual angle. Design the quadrant here. S is positive, y is negative. If S is positive, y is negative, angle theta terminates in quadrant 4. Since S is positive, y is negative, angle theta terminates in quadrant 4. Since theta belongs to quadrant 4, actual angle theta is 2 pi minus the reference angle. Since angle theta terminates in quadrant 4, the actual angle is 2 pi minus the reference angle. Then that's angle theta. It doesn't look nice, but that's what it is. So the answer is r radical 10. Angle theta 2 pi minus inverse tangent of 1/3. It doesn't look nice, but that's what it is. Leave it the way it is. Next, convert the Cartesian point negative radical 3, 3 to polar coordinates. Since this is a Cartesian point, x equal to negative radical 3, y equal to 3. Let's find r first. R squared is s squared plus y squared, which is negative radical 3 squared plus 3 squared. Negative radical 3 squared is 3. 3 squared is 9. 3 plus 9 is 12. So r equal to radical 12. Radical 12 can be rewrite as 2 radical 3. That's r. Next, try to find theta. Tangent theta is y over x. Tangent theta is y over x. If we plug in s and y, tangent theta is 3 over negative radical 3. Which can be reduced as negative radical 3. Then for the reference angle, we use inverse tangent of vertical 3. Reference angle is always positive, so we must take absolute value, drop negative sign. Inverse tangent of vertical 3. Inverse tangent of vertical 3, that's a special value, which is pi over 3. Tangent pi over 3 is vertical 3. So inverse tangent of vertical 3 is pi over 3. That's a reference angle. Next, determine the quadrant. X is negative, y is positive. Since x is negative, y is positive, this point located in quadrant 2. This point located in quadrant 2. So angle theta terminates in quadrant 2. Since angle theta terminates in quadrant 2, theta is inverse tangent is pi minus the reference angle. Since theta terminates in quadrant 2, theta is pi minus the reference angle, which is pi minus pi over 3. Pi minus pi over 3 is 2 pi over 3. So the polar coordinate is 2 radical 3 comma 2 pi over 3. It's the polar coordinate of this Cartesian point. Next, we will study polar curves. What is a polar curve? If r is a function of theta, if r is a function of theta, then the set of all points, that satisfy the equation r equal to r of theta. In general, it forms a curve. It forms a curve in general, and this curve is called a polar curve. Next, let me show you how to graph polar curves. Look at a simple example first. Sketch each of the following polar curves. Sketch each of the following polar curves. Look at a simple one. R equal to 4 sine theta. How do we sketch this polar curve? R equal to 4 sine theta. Here R is a function of theta. How do we graph the polar curve? R equal to 4 sine theta. So to sketch a curve, we try to make table. Since r depends on theta, so in the table we put theta on the left side, put r on the right side. Then pick some value for theta. Since theta represents radial measure of the angle, let's pick theta to be 0 pi over 2. Let's try 0 pi over 2, pi, 3 pi over 2, and 2 pi. Let's try to make the gap to be pi over 2, see if it works. If we can't get a curve, we need to make the gap smaller. If we can't get a curve based on this point, we need to make the gap smaller. We need to plot more points. If theta is 0, sine 0 is 0, I get 0 here. If theta is pi over 2, sine pi over 2 is 1, 4 times 1 is 4. If theta is pi, sine pi is 0, I get 0. If theta is 3 pi over 2, sine 3 pi over 2 is negative 1, negative 1 times 4 is negative 4. if theta is 2 pi, sine 2 pi is 0. Let's plot this 5 point, see if we can make a curve or not. First point, when theta is 0, r is 0, we are here. That's the first point. Second point, when theta is pi over 2, r is 4. Pi over 2 is here. So we consider this as positive deduction. When theta is pi over 2, we consider this as positive deduction. R is 4. Go 4 units from this deduction. 1, 2, 3, 4. That's the second point. That's the second point. That's first, second. Third point, when pi is 0, r is 0. When theta is pi, r is 0. We are here. That's the third point. First point, second point, third point. Next, when theta is 3 pi over 2, r is negative 4. 3 pi over 2 is here. We consider this is positive deduction. When theta is 3 pi over 2, we consider this is positive deduction. Here r is negative 4. So go to the opposite direction. Negative 1, negative 2, negative 3, negative 4, we are here. That's the fourth point. The fifth point, when theta is 2 pi, r is 0. We go back to origin. So that's the first point, second point, third point, fourth point, fifth point. We go back and forth between these 2 points. We can make a curve. That means the gap here is too big. Let's try to make the gap smaller. The gap between these points are too big. Let's make the gap smaller. Let's use pi over 4 as the gap. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. Then 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. Let's plot more points. The more point we plot, the better curve we have. In general, the more point we plot, the better curve we have. So when theta is pi over 4, sine pi over 4 is radical 2 over 2, which is 2 radical 2. When theta is pi over 2, sine pi over 2 is 1, so I get 4. When theta is 3 pi over 4, then this angle is in quadrant 2. Sine function in quadrant 2 is positive. Reference angle is pi over 4. Sine pi over 4 is radical 2 over 2. Radical 2 over 2 times 4 is 2 radical 2. Sine pi is 0. Sine 5 pi over 4. 5 pi over 4 terminates in quadrant 3. Sine function in quadrant 3 is negative. And reference angle is pi over 4. Sine pi over 4 is radical 2 over 2. And sine function is negative in quadrant 3, so it's negative radical 2 over 2 times 4 is negative 2 radical 2. Sine 3 pi over 2 is negative 1. 4 times negative 1 is negative 4. Sine 7 pi over 4. 7 pi over 4 terminates in quadrant 4. Sine function in quadrant 4 is negative. Reference angle is pi over 4. Sine pi over 4 is radical 2 over 2. Since sine is negative in quadrant 4, sine 7 pi over 4 is negative radical 2 over 2 times 4 is negative 2 radical 2. Sine 2 pi is 0. Then plot these points. Let me remove everything first. Otherwise it's very confused. Let me remove everything first. When theta is 0, r is 0. That's the first point. When theta is pi over 4, this is angle pi over 4. We assume this is the positive direction. R is 2 radical 2. 2 radical 2 is 2.8. It's almost 3 units. 1, 2, 3, almost 3 units somewhere here. That's the second point. First point, second point. Third point, when theta is pi over 2, r is 4. 1, 2, 3, 4. When we have 3 points, we can connect 3 points using smooth curve. When we have 3 points, if they don't lie on the same line, we can connect 3 points using smooth curve. We can connect 3 points using smooth curve. It goes this way as theta increase. It goes this way as theta increase. Next, when theta is 3 pi over 4, 3 pi over 4 is here. That's an angle 3 pi over 4. When theta is 3 pi over 4, we consider this is in a positive direction. R is 2 radical 2. 2 radical 2 is about 2.8, a little less than 3. So 1 unit, 2 unit, almost 3 unit, somewhere here, almost 3 unit, somewhere here. Next, when theta is pi, r is 0, we go back to the origin. We can connect 3 points using smooth curve. We can connect 3 points using a smooth curve. And that's the direction, it's theta increase. Next, when theta is 5 pi over 4, 5 pi over 4 somewhere here. So when theta is 5 pi over 4, we consider this is in a positive direction. When theta is 5 pi over 4, we consider this is in a positive direction. R is negative 2 radical 2. So if this is positive direction, when r is negative 2 radical 2, we must go to the opposite direction. So negative 2 radical 2 is about negative 2.8, almost 3 units, 1, 2, somewhere here. So when theta is 5 pi over 4, we get a point here. The same point as we have when theta is pi over 4. Next, when theta is 3 pi over 2, r is negative 4. 3 pi over 2 is here. We consider this is the positive direction when theta is 3 pi over 2. Now when r is negative 4, go to the opposite direction. Negative 1, negative 2, negative 3, negative 4. We have 3 points here. Connect 3 points using smooth curve. We can see that the curve repeats itself. The curve repeats itself. When theta is 7 pi over 4, 7 pi over 4 somewhere here. That's 7 pi over 4. When theta is 7 pi over 4, we consider this is in a positive direction. We consider this is in a positive direction. Then here, r is negative 2 radical 2. Since r is negative, we need to move to the opposite direction. Since r is negative 2 radical 2, 2 radical 2 is 2.8. So it's about negative 2.8. 1, 2, almost 3 units here. So you can see that it repeats itself. When theta is 2 pi, we get 0. Go back to origin. So connect 3 points using smooth curve. The curve repeats itself. So you can see that that's the graph of this function. This is called a polar curve of this polar function. That's the polar curve of this polar function. Next example. R equal to 2 cosine 3 theta. So in order to sketch a polar curve, let's make a table for r and theta first. What should we choose for theta here? Theta starts from 0. What should we choose for next? Let's try this. For cosine function, the perimeter is 3 theta. Try to set 3 theta equal to pi over 2. Then theta is pi over 6. Let's try to use pi over 6 as a gap. For theta, let's try to use pi over 6 as a gap. Then 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, finally 12 pi over 6, 2 pi. Let's try to pick theta for values from 0 to 2 pi. Usually you choose theta from 0 to 2 pi. Now, let's plug in. When theta is 0, cosine 0 is 1. We get 2 here. When I plug in pi over 2, when I plug in pi over 6, pi over 6 times 3 is pi over 2. Cosine pi over 2 is 0. When I plug in pi over 3, 3 times pi over 3 is pi. Cosine pi is negative 1. 2 times negative 1 is negative 2. When I plug in pi over 2, I get cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. When I plug in 2 pi over 3, I get cosine 2 pi. Cosine 2 pi is 1. 1 times 2 is 2. I plug in 5 pi over 6, I get 5 pi over 2. Cosine 5 pi over 2 is 0. When I plug in pi is negative 1. 2 times negative 1 is negative 2. It looks like the pattern here is 0, positive 2, 0, negative 2, 0, positive 2. That's the points. Now let's plot the point in the xy plane. Let's plot the point in the xy plane. When theta is 0, r is 2. Theta is 0, we are here. R is 2. When theta is 0, this is a positive direction. R is 2. 1, 2. That's the point. When theta is pi over 6, when theta is pi over 6, that's the positive direction. R is 0. So from 0 to pi over 6, it goes this way. When theta is pi over 3, pi over 3 is somewhere here. It's pi over 3. This is considered to be the positive direction. When theta is pi over 3, this is considered positive direction. R is negative 2. So we need to find R in the opposite direction. 1, negative 1, negative 2. That's the point. Pi over 3, comma, negative 2. When theta is pi over 3, R is negative 2. That's the second point. Then we can connect 3 points using smooth curve. We can connect these 3 points using smooth curve. In general, we can connect 3 points using smooth curves. Connect 3 points using smooth curves. In general, we connect 3 points using smooth curves. Then next, when theta is pi over 2, R is 0. We are here. When theta is 2 pi over 3, 2 pi over 3 is somewhere here. When theta is 2 pi over 3, that's the positive direction. R is 2. One, 2. Then connect 3 points using smooth curves. We can connect these 3 points using smooth curves. Connect these 3 points using smooth curves. The curve must be smooth. Connect 3 points using smooth curves. So you go this way, this way, this way back, this way. Next, when theta is 5 pi over 6, you get 0. This is 5 pi over 6. When theta is pi is here. That's in the positive direction. When theta is pi. R is negative 2. We have 1, 2. Then connect these 3 points. Connect 3 points, we can make smooth curve. Connect these 3 points, we can make smooth curve. connect these 3 points using smooth curve. Connect 3 points using smooth curve. That's what we have here. Then when theta is 7 pi over 6, 7 pi over 6 somewhere here. It's 7 pi over 6. When theta is 7 pi over 6, we get 0. Next, 4 pi over 3. When theta is 4 pi over 3, we are here. R is 2. So we have 3 points here. Connect these 3 points using smooth curve. We get exactly the same path here. Next, when theta is 3 pi over 2, we are here. R is 0. The points in the origin. When theta is 5 pi over 3, we are here. Theta is 5 pi over 3. We consider this is positive direction. When theta is 5 pi over 3, we consider this is positive direction. R is negative 2. Go to the opposite direction here. The point is here. Connect 3 points using smooth curve. The same path repeats itself. Next, when theta is 11 pi over 6, is here. R is 0. We go back to origin. When theta is 2 pi is the same as 0. 2 pi complete one cycle, go back to 0. R is 2. The point is here. Connect 3 points using smooth curve. We get exactly the same path. So that's a complete graph for this function, for this polar function. That's a complete graph for this polar function. Next, R equal to 4. This is a constant function. How do we graph this constant function? Same thing, let's make a table. For R and theta. Assume R is a function of theta. When theta is 0, R is 4. When theta is pi over 2, R is 4. Since R is constant, R doesn't depends on theta. When theta is pi, R is 4. When theta is 3 pi over 2, R is 4. When theta is 2 pi, R is 4. Price points. When theta is 0, R is 4. When theta is 0, R is 4. 1, 2, 3, 4 points here. When theta is pi over 2, R is 4. 1, 2, 3, 4, somewhere here. When theta is pi, that's in the positive direction. R is 4. 1, 2, 3, 4. That's the point. When theta is 3 pi over 2, R is 4. 1, 2, 3, 4. When theta is 2 pi, R is 4. 2 pi is the same as 0. 1, 2, 3, 4. Then, connect this point, we can make a curve. Connect this point using smooth curves. Then that's the direction as theta increase. That's the direction as theta increase. It looks like a circle. Next example, theta equal to pi over 4. Here we don't see R as a function of theta. How can we sketch this graph? Here we don't see R as a function of theta. So let's graph based on what we know so far. All we know is theta equal to pi over 4. Theta is 0, pi over 4 somewhere here. All we know is theta equal to pi over 4. All we know is theta equal to pi over 4. When r is 0, we have a point here. When r is 1, we have a point here. When r is 2, we have a point here. When r is 3, 4, 5, and when r is -1, we have a point here. -2, -3, and so on. So as r varies, we have a line here. As r varies, we have a straight line. As r varies, we have a straight line. As r varies, we have a straight line. That's the graph for this equation. Now, based on this 4 example, we see that we can sketch polar curve by plotting points. But sometimes they are too much work. Is there a better way to sketch polar curve other than plotting points? Is there another way to sketch polar curve other than plotting points? Let's look at this equation here. We have r equal to 4 sine theta. If I can write this equation in terms of x and y, then it would be much easier to sketch graph. If I can write this equation in terms of x and y, then it will be much easier to sketch graph. Can we rewrite this equation in terms of x and y? Let's try. In this example, we have r equal to 4 sine theta. If I multiply both sides of the equation by r, I have r squared equal to 4 times r sine theta. If I multiply both sides of the equation by r, I get r squared equal to 4 times r sine theta. Then we know that there's a formula that says x squared plus y squared equal to r theta. Tangent theta is y over x. X is r cosine theta. Y is r sine theta. Try to use this formula to write the equation in terms of x and y. Here, r squared is the same as x squared plus y squared. R squared is the same as x squared plus y squared. R sine theta is y. If I move everything over, I have x squared plus y squared plus 4y equal to 0. Y squared minus 4y equal to 0. If I try to complete square for y, here, I can add 4 to both sides. I have x squared plus y squared minus 4y plus 4 equal to 4. Then complete square, I have complete the square here. I have x squared plus y minus 2 squared equal to 2 squared. We can see that that's a circle. Center at the point 0, 2 with radius 2. There's a circle centered at a point 0, 2 with radius 2. So you can see here in the picture, it's a circle centered at 0, 2 with radius 2. So if we try to use this equation, it's much easier to sketch the curve. So in general, when you see a polar equation, if you can write it in terms of x and y, then it will be much easier to sketch the graph. Otherwise, we must plot points. There's no shortcut. If we can write it in terms of x and y, we must plot points. Like example 2, I don't see an easier way to write this in terms of x and y, so we must plot points. For the second example here, I don't see an easier way to write this equation in terms of x and y, so we must plot points here. For example 3, can we rewrite this equation in terms of x and y? For example 3, can we rewrite this equation in terms of x and y? For example 3, the equation is r equal to 4. If I square both sides, r squared equal to 4 squared. And we know that r squared is 16 here. R squared is x squared plus y squared. R squared can be rewritten as x squared plus y squared. So we get x squared plus y squared equal to 16. That's a circle center and origin. With radius 4. That's a circle center and origin with radius 4. If we convert this to an equation with x and y, it's much easier to sketch a graph. Next, theta equal to pi over 4. Can we rewrite this equation as an equation of s and y? Can we rewrite this equation in terms of s and y? We have theta equal to pi over 4. If I apply tension to both sides, I have tension theta equal to tension of pi over 4. That means tension of theta is 1. Tension pi over 4 is 1. And we know that tension of theta can be rewritten as y over x. Tension of theta can be rewritten as y over x. Multiply both sides by x. We have y equal to x. So this is the equation of this line. This is the equation of this line. So in general, if we can write a polar equation in terms of s and y, then it will be easier to sketch the graph. Next example, r equal to 2 cosecant theta. If we try to graph this polar curve by plotting points, it may be too complicated, maybe too much work. An easier way is we can try to rewrite this equation in terms of x and y. Then graph the equation with x and y will be much easier. So let's try to rewrite this equation in terms of x and y. What can we do first? We know that cosecant can be rewritten as 1 over sine. If I multiply both sides by sine theta, I have r sine theta equal to 2. We know that r sine theta is y. So you got y equal to 2. That's a horizontal line passing through 2 in the y-axis. That's a horizontal line passing through 2 in the y-axis. What's the direction of this line as theta increase? What's the direction of this line as theta increase? So in order to see the direction, let's test 2 points. Let's test 2 points. When theta is 0, cosecant of 0 is undefined. So that's a bad point to test. That's a bad test point. Let's test for pi over 6. When theta is pi over 6, r is 2 cosecant pi over 6. Cosecant can be written as 1 over sine. So that's 2 times 1 over sine pi over 6. Sine pi over 6 is half. 1 over half is 2. I get 2 times 2, which is 4. So when theta is pi over 6, radius is 4. That's when theta is pi over 6. We have a point here when theta is pi over 6. Next, let's test for theta equal to pi over 3. When theta is pi over 3, r is 2 cosecant pi over 3. Cosecant can be rewritten as 1 over sine. So I have 1 over sine pi over 3. Sine pi over 3 is radical 3 over 2. So the reciprocal is 2 over radical 3, which is 4 over radical 3. So when theta is pi over 3, the point is 4 over radical 3. That's the point when theta is pi over 3. So as theta increase, it goes this way. As theta increase, it goes this way. That's the direction as the theta increase. Next example. R equal to tension theta times secant theta. R equal to tension theta times secant theta. If we try to graph this equation by plotting points, it may be too much work. If we try to graph this equation by plotting points, it may be too much work. So let's try to rewrite this equation in terms of x and y. Then graph the equation in terms of x and y will be much easier. Let me rewrite the trig function first. So, tension theta can be rewritten as sine theta over cosine theta. Secant theta can be rewritten as 1 over cosine theta. Then if I multiply both sides by cosine square theta, if I multiply both sides by cosine square theta, I have r cosine theta times cosine theta equal to sine theta. If I multiply both sides by cosine square theta, then I can multiply both sides by r. I get r cosine theta times r cosine theta equal to r sine theta. We know that r cosine theta is x. r sine theta is y. So the equation is y equal to x. That's the equation in terms of x and y. Graphing this equation is much easier than graphing this equation by plotting points. So y equal to x squared is a parabola open upward, passing through the origin. That's a graph y equal to x squared. What's the direction? What's the direction of this curve? So let's test some points. Let's test 2 points. When theta is 0, r equal to tangent 0 is 0, secant 0 is 1, 0 times 1 is 0. When theta is 0, r is 0, we are here. That's the point when theta is 0. Let's test a different point. When theta is pi over 4. When theta is pi over 4, tangent pi over 4 is 1. Secant pi over 4. Secant is a reciprocal of cosine. Cosine pi over 4 is 1 over radical 2. So secant pi over 4 will be radical 2. 1 times radical 2 is radical 2. So when theta is pi over 4, when theta is pi over 4, r is radical 2. That's the second point, when theta is pi over 4. So here we see the direction. The curve goes this way. That's the direction of the polar curve. As theta increases, that's the direction of the polar curve. So here we know that when we try to sketch graph, if we rewrite a polar equation in terms of x and y, we can sketch the graph in a much easier way. But sometimes, for integration purpose, we want to rewrite a Cartesian equation in terms of I and theta. How can we do that? Look at the following examples. Rewrite each of the following equations as a polar function. Sometimes, for some integration purpose, we want Cartesian equation in terms of I and theta. What can we do? For example, we have x squared plus y squared minus 10x equal to 0. How can we run this equation in terms of I and theta? Use the formula x squared plus y squared equal to r squared, and tangent of theta is y over x, s is r cosine theta, y is r sine theta. Try to use these 4 equations to rewrite this Cartesian equation in terms of I and theta. Here, x squared plus y squared is r squared minus 10x, x is r cosine theta. Now try to solve this equation for r. If I divide both sides by r, I have r minus 10 cosine theta equal to 0. Then I can isolate r here, r equal to 10 cosine theta. This is a polar function. Sometimes for some integration purpose, using this function will be much easier than using the Cartesian equation. Next example, y squared equal to 4x. Y squared equal to 4x. I can replace this y with r sine theta. So I get r sine theta squared. I can replace this x with r cosine theta. Then left side is r squared sine squared theta. Right side is 4r cosine theta. I can divide, first of all, divide both sides by r. I get r sine squared theta equal to 4 cosine theta. If we want to isolate r, I can divide both sides by sine squared theta. So I get r equal to 4 cosine theta over sine squared theta. If I try to simplify the right side, it can be rewritten as 4 times cosine theta over sine theta times 1 over sine theta. And we know that cosine theta over sine theta is cosecant. cosine theta over sine theta is cotension. That's cotension of theta. 1 over sine theta is cosecant theta. Next, let me introduce the derivative of a polar curve. Let R be a function of theta. Then we can write R as R of theta. Then we can write R as R of theta. Since we know that in polar coordinate system, X is R cosine theta, Y is R sine theta, then X can be written as R of theta times cosine of theta. Since R is a function of theta, R can be written as R of theta times cosine theta. S is R of theta times cosine theta. Y is R of theta times sine theta. Then we can see that both X and Y, they are functions of theta. Both X and Y, they are functions of theta. So if we're looking for the derivative of the function, dy over dx, we can consider X and Y, they are both functions of theta. We can consider their parametric equations with perimeter of theta. We can consider X and Y, they are parametric equations with perimeter theta. They are parametric equations with theta as a parameter. So we can consider X and Y. They are parametric equations with theta as a parameter. Then dy over dx can be written as dy over d theta over dx over d theta. Then for the numerator, how do we find dy over d theta? For dy over d theta, we use product rule. Derivative of the first times the second, derivative of the first times the second, plus the first times derivative of the second. Derivative of sine is cosine. That's the numerator. For denominator, dx over d theta, use product rule again. Derivative of the first times the second, plus the first times derivative of the second. Then if we simplify, dy over dx can be rewritten as r prime of theta here is dr over d theta. R prime of theta is dr over d theta times sine theta. R of theta I can write it as r times cosine theta. On the bottom, r prime of theta I can write it as dr over d theta times cosine theta. Then I can pull out negative sign, right? Minus r of theta I can write it as r times sine theta. That's the derivative for polar curve. Assuming the denominator is not zero. That's the derivative of a polar curve. Next, let's look at an example. Let r equal to 3 minus 2 sine theta be a polar curve, but the slope of the tangent line is theta equal to pi over 2. So in order to find the slope of tangent line, let's first of all compute the derivative. Derivative represents slope of tangent line. So derivative dy over dx. That's dr over d theta times sine theta plus r times cosine theta. Dr over d theta times cosine theta minus r times sine theta. That's r. What's dr over d theta? Since r is 3 minus 2 sine theta, dr over d theta is negative 2 cosine theta. That's dr over d theta. Then we plug in r and dr over d theta. dr over d theta is -2 cosine theta, then times sine theta, plus r. R is 3 minus 2 sine theta. Times cosine theta over dr over d theta. It's -2 cosine theta times cosine theta minus r. R is 3 minus 2 sine theta times sine theta. Then we try to find the slope of tangent line by plugging in theta is pi over 2. So for the slope of tangent line, I plug in that theta equal to pi over 2. Plugging theta equal to pi over 2. Cosine pi over 2 is 0. Sine pi over 2 is 1. Sine pi over 2 is 1. 3 minus 2 is 1. Cosine pi over 2 is 0. Cosine pi over 2 is 0 on the bottom. Cosine pi over 2 is 0. Sine pi over 2 is 1. 3 minus 2 is 1. Sine pi over 2 is 1. So we get 0 over 1. We get 0 over 1, which is 0. So the slope of tangent line at theta is equal to pi over 2 is 0. That's the slope of tangent line at theta equal to pi over 2. Next example. Let r equal to 4 sine theta be a polar curve. Part A, find the equation of the tangent line at theta equal to pi over 6. Part B, find all points where the tangent line is either horizontal or vertical. So let's do part A first. In part A, we're looking for equation of tangent line. For equation of a line, we need to know the slope at a point. For the slope, we can compute the derivative. For a point, we can use the formula x equal to r cosine theta, y equal to r sine theta to find a point. So let's compute the slope first. For part A, in order to find the slope, we need to find the derivative, dy over dx. dy over dx, the formula is dr over d theta times sine theta plus r times cosine theta over dr over d theta times cosine theta minus r sine theta. Then, since r is 4 sine theta, dr over d theta will be 4 cosine theta. So we can plug in here. 4 cosine theta times sine theta plus r by itself is 4 sine theta times cosine theta over the denominator, dr over d theta is 4 cosine theta times cosine theta minus r is 4 sine theta times sine theta. Then for the slope of tangent line, we plug in. For the slope of tangent line, we plug in. Theta is pi over 6. When theta is pi over 6, we have 4 times cosine pi over 6. Cosine pi over 6 is radical 3 over 2 times sine pi over 6. Sine pi over 6 is half plus 4 times sine theta. Sine pi over 6 is half times cosine theta. Cosine pi over 6 is radical 3 over 2 over the denominator 4 times cosine theta. Cosine pi over 6 is radical 3 over 2 times another cosine theta, that's another radical 3 over 2 minus 4 times sine theta. Sine pi over 6 is half. Sine pi over 6 is half Then simplify. In the numerator, I get radical 3 plus radical 3. And on the denominator, I get 3 minus 1. That's 2 radical 3 on the numerator and 2 on the bottom. Cancel 2, I get radical 3. So the slope of the tension line is radical 3. Once I know the slope, I need to know a point. We know for a point, x is r cosine theta, y is r sine theta. When theta is pi over 6, r equal to 4 times sine pi over 6. When theta is pi over 6, r is 4 times sine pi over 6. Sine pi over 6 is half. 4 times half is 2. And we know x is r cosine theta, which is 2 times cosine pi over 6. Cosine pi over 6 is radical 3 over 2. So x coordinate is radical 3. Y coordinate is r sine theta, which is 2 times sine pi over 6. Sine pi over 6 is half. 2 times half is 2. 2 times half is 1. So the point when theta is equal to pi over 6, the point is radical 3, comma 1. When theta equal to pi over 6, the point on the curve is radical 3, comma 1. Then once we know the point, we know the slope, we can find equation of tension line. Equation of tension line, the formula is y minus y0 equal to m times x minus x0. Then plug in y minus 1 equal to m times x minus radical 3. That's x0, that's y0. Then simplify. If I distribute radical 3, I get radical 3x minus 3. Add 1 to both sides. Y is radical 3x minus 2. That's the equation of tension line when theta equal to pi over 6. Part B. Find the point when the tension line is either horizontal or vertical. We know that when the tension line is horizontal, the slope must be 0. And when the tension line is vertical, the slope must be either positive or negative infinity. So in order to make the slope 0, we set the numerator of the derivative to be 0. In order to make the slope to be undefined, we set the denominator of the derivative to be 0. So for horizontal tension line, we set the numerator of the derivative equal to 0. We set the numerator of the derivative equal to 0. For horizontal tension line, set the numerator of the derivative equal to 0. For vertical tension line, set the denominator of the derivative equal to 0. Set the denominator of the derivative equal to 0. For horizontal tension line, set the numerator of the derivative equal to 0. For vertical tension line, set the denominator of the derivative equal to 0. Then solve both equations for theta. In the first equation, if I combine like term, it can be written as a times cosine theta sine theta equal to 0. Then apply double angle formula. A times sine theta cosine theta can be written as 4 times 2 sine theta cosine theta equal to 0. 2 sine theta cosine theta is sine 2 theta. So you get 4 sine 2 theta equal to 0. Solve the equation for theta. We get sine 2 theta equal to 0. Sine function occurs 0. Sine function occurs 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and so on. So sine function occurs 0. Sine function occurs 0 at 0, pi, 2 pi, 3 pi, 4 pi, and so on. So here, 2 theta should be 0, plus minus pi, plus minus 2 pi, and so on. Because sine function can go to the other side. That's negative pi, negative 2 pi, negative 3 pi, and so on. So 2 theta could be 0, plus minus pi, plus minus 2 pi, and so on. If we try to solve for theta, I divide both sides by 2. So theta equal to 0, plus minus pi over 2, plus minus pi, plus minus, the other one should be 3 pi over 2, and so on. Now here, what should we choose for theta? What should we pick theta value here? In order to choose a value for theta, let's sketch the graph. Let's sketch the graph r equal to 4 sine theta. The curve of r equal to 4 sine theta, it's a circle. The graph of r equal to 4 sine theta is a circle. And this graph complete one cycle when theta value is from 0 to pi. When theta value from 0 to pi, it complete one cycle. When theta is 0, we are here. When theta is pi over 4, we are here. When theta is pi over 2, we are here. That's the left side curve. That's the right side curve. The right half semicircle. When theta is 3 pi over 4, r is 2 radical 2, we are here. When theta is pi, we are here. That's the left half semicircle. So from 0 to pi, it complete one cycle. So when we are looking for solution, we're only looking for theta between 0 and pi. Since this polar curve complete one cycle for theta from 0 to pi, we are only looking for solution from 0 to pi. So we can take theta equal to 0, pi over 2, and pi. From 0 to pi, this polar curve complete one cycle. So pick the solution from 0 to pi. The value between 0 and pi is 0, pi over 2, and pi. That's the solution for the numerator. Now let's solve an equation for the denominator. Set denominator equals 0. Solve an equation for theta. Here I can factor 4 out. If I factor 4 out, I have cosine squared theta minus sine squared theta equal to 0 if I factor 4 out. Then we have cosine squared theta minus sine squared theta. Apply double angle formula. Cosine squared theta minus sine squared theta is cosine 2 theta. Theta equals 0. I get 4 cosine 2 theta equals 0. Then I can divide both sides by 4. If I divide both sides by 4, cosine 2 theta is 0. Cosine function occurs 0 at where? If we graph y equal to cosine of x, cosine function occurs 0 where? That's pi over 2. That's 3 pi over 2, 5 pi over 2, 7 pi over 2. If the curve continues on the other side, we have negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So the solution is odd number times pi over 2. The solution for cosine equal to 0. Theta x must be odd number times pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So it must be plus minus pi over 2, odd number times pi over 2, 3 pi over 2, odd number times pi over 2, plus minus 5 pi over 2, and so on. In order to get theta by itself, I divide both sides of the equation by 2. If I divide both sides by 2, theta equal to plus minus pi over 4, plus minus 3 pi over 4, plus minus 5 pi over 4, and so on. Since we know that this polar curve complete one cycle for theta between 0 and pi. This polar curve complete one cycle when theta is from 0 to pi. So we are only looking for solution from 0 to pi. We are only looking for solution from 0 to pi. Between 0 and pi, we have pi over 4 and 3 pi over 4. Between 0 and pi, we have pi over 4 and 3 pi over 4. Then for each theta, we find a point. For each theta, we find a point. When theta is 0, r is 4 sine theta, which is 4 times sine 0. Sine 0 is 0, we get 0. When r is 0, s is r cosine theta. 0 times cosine theta is 0. Y is r sine theta. 0 times sine theta is also 0. So a point here is 0, 0. That means at point 0, 0, the tangent line is horizontal. When theta is pi over 2, r is 4 sine pi over 2. When theta is pi over 2, r is 4 sine pi over 2. Pi over 2. Sine pi over 2 is 1. 4 times 1 is 4. So x is r cosine theta. That's 4 times cosine pi over 2. Cosine pi over 2 is 0. So x coordinate is 0. Y is r sine theta, which is 4 times sine pi over 2. Sine pi over 2 is 1. 4 times 1 is 4. So that's a point 0, 4. When theta equal to pi over 2, the point on the curve is pi 0, 4. When theta equal to pi, r is 4 sine pi. Sine pi is 0. 4 sine pi is 0. When r is 0, s equal to r cosine theta. When r is 0, 0 times cosine theta is 0. Y is r sine theta. If I plug in 0, for r, 0 times sine theta is 0. So that's a point 0, 0. This point and this point is the same. So don't repeat, only write it once. This point and this point is the same point, only write it once. Don't repeat the points. Now, when theta is pi over 4, r is 4 times sine pi over 4. Sine pi over 4 is 2 over radical 2, which is, so that's radical 2 over 2, which is 2 radical 2. X is r cosine theta. R is 2 radical 2. Cosine pi over 4 is radical 2 over 2. R is 2 radical 2. Cosine pi over 4. If I plug in pi over 4 for theta, cosine pi over 4 is radical 2 over 2. Cancel 2. Radical 2 times radical 2 is 2. Y is r sine theta. R is 2 radical 2. Sine theta, if I plug in pi over 4, sine pi over 4 is radical 2 over 2. 2 get cancelled. Radical 2 times radical 2 is 2. So the point is 2, 2. When theta is pi over 4, the point on the curve is 2, 2. When theta equal to 3 pi over 4, r equal to 4 sine 3 pi over 4. For sine 3 pi over 4, 3 pi over 4 terminates in quadrant 2. Sine function in quadrant 2 is positive. And for 3 pi over 4, reference angle is pi over 4. Sine pi over 4 is radical 2 over 2. And sine function in quadrant 2 is positive. So we get 2 radical 2. So when theta is 3 pi over 4, r is 2 radical 2. Then we find x and y. X is r cosine theta. r is 2 radical 2. Cosine 3 pi over 4. Angle 3 pi over 4 terminates in quadrant 2. Cosine function in quadrant 2 is negative. And for 3 pi over 4, reference angle is pi over 4. Cosine pi over 4 is radical 2 over 2. Cancel 2 on the bottom. I get negative 2. Radical 2 times radical 2 is 2. And there's a negative sign here. Y is r sine theta. R is 2 radical 2. Sine theta, sine 3 pi over 4, we have it here. It's radical 2 over 2. Cancel 2 from bottom, we get 2. So the point on the curve is negative 2 comma 2. The point on the curve is negative 2 comma 2 when theta equals 3 pi over 4. So the answer, horizontal tension line occurs at point 0, 0 and 0, comma 4. Vertical tension line occurs at point 2, comma 2 and negative 2, comma 2. If we look at the picture, we can see that horizontal tension line occurs at point 0, 0 and 0, comma 4. Vertical tension line occurs at these 2 points. This is 2, comma 2. That's negative 2, comma 2. That's the point where tension line is horizontal. And that's the point where tension line is vertical. And let's match what we have here. And if a point repeats, don't write it twice. If 0, 0 repeats, don't write it twice. Only write it once. Next example. Let r equal to 1 minus cosine theta be a polar curve. Find all points where the tension line is either horizontal or vertical. We know that if a line is horizontal, its slope must be 0. And if a line is vertical, its slope must be positive or negative infinity. So when the tension line is horizontal, the numerator of the derivative must be 0. And when the tension line is vertical, the denominator of the derivative must be 0. So let's compute the derivative first. dy over dx is dr over d theta times sine theta plus r times cosine theta over dr over d theta times cosine theta minus r times sine theta. Then here we know that r is 1 minus cosine theta. dr over d theta is positive sine theta. Take derivative for cosine. I get negative sine theta, which is positive sine theta. Then plug in. dr over d theta is sine theta times sine theta plus r. R is 1 minus cosine theta times cosine theta. On the denominator, we have dr over d theta, which is sine theta, times cosine theta, minus r. R is 1 minus cosine theta times sine theta. That's the derivative. Let's dy over dx. Then, for horizontal tension line, we set the numerator equal to 0. We set sine theta times sine theta plus 1 minus cosine theta times cosine theta equal to 0. For vertical tension line, I set the denominator equal to 0. So I set sine theta times cosine theta minus 1 minus cosine theta times cosine theta equal to 0. Then we solve both equations for theta. Let me simplify the first equation first. In the first equation, sine theta times sine theta is sine squared theta. If I distribute cosine theta, I have cosine theta minus cosine squared theta equal to 0. Next, I try to write sine in terms of cosine. I try to write sine in terms of cosine. Sine squared of theta can be rewritten as 1 minus cosine squared of theta plus cosine of theta minus cosine square of theta. Then if I combine like terms, I have negative 2 cosine squared theta plus cosine theta plus 1 equal to 0. If I multiply both sides by negative 1, I get negative 2, I get 2 cosine squared theta cosine squared theta minus cosine theta minus 1 equal to 0. Then I can factor this equation. 2 cosine squared theta can be factored as 2 cosine theta times cosine theta. Then I try to make the outer and the inner to be negative 1 theta. So I can take the outer here to be 2 cosine theta times negative 1 plus 1 cosine theta. That's negative cosine theta. After factor, I set each of them equal to 0. 2 cosine theta plus 1 equal to 0. Cosine theta minus 1 equal to 0. Set each part equal to 0. Then solve each equation for theta. If I solve the first equation for theta, theta is negative 1 over 2. So cosine theta is negative 1 over 2. If I solve the second equation for theta, cosine theta is 1. Cosine theta occurs 1 at where? If we draw the graph, cosine theta occurs 1 at 0, 2 pi, 4 pi. On the other side is negative 2 pi, negative 4 pi. So that's cosine of x. So cosine function occurs 0 at cosine theta occurs at 1 at 0, 2 pi, 4 pi, and so on. Here theta equal to 0, plus minus 2 pi, plus minus 4 pi, and so on. What should we pick for this value? What should we pick? Let's sketch the graph first. We want to know for which theta value the curve complete one cycle. Because in the infinite dimensional solution, we cannot solve everything here. So let's see. Draw the graph and find out for which theta value this polar curve complete one cycle. Theta and r. Let's pick values for 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's try this point first. If we can graph it, we may need to pick more points. Let's try this 5 point first. If I plug in 0, cosine 0 is 1. 1 minus 1 is 0. If I plug in pi over 2, cosine pi over 2 is 0. 1 minus 0 is 1. If I plug in pi, cosine pi is negative 1. 1 minus negative 1 is 2. If I plug in 3 pi over 2, cosine 3 pi over 2 is 0. 1 minus 0 is 1. If I plug in 2 pi, cosine 2 pi is 1. 1 minus 1 is 0. Now let's plot point and sketch the polar curve. If I plug in 0, when theta is 0, r is 0. So the point is on the origin. When theta is pi over 2, r is 1. This is pi over 2. R is 1. When theta is pi over 2, r is 1. When theta is pi, r is 2. Connect 3 points using smooth curve. We try to connect these 3 points using smooth curve. So it must look like this. If we connect these 3 points using smooth curve, it must look like this. If we connect these 3 points using smooth curve, it must look like this. use smooth curve to connect these 3 points. It looks like this. When theta is 3 pi over 2, when theta is 3 pi over 2, that's in the positive direction. R is 1. The point is here. When theta is 2 pi, R is 0. We'll go back to the origin. Connect these 3 points using smooth curve. Connect these 3 points using smooth curve. That's the direction of the polar curve as theta increase. So you see that from 0 to 2 pi, this polar curve complete one cycle. It starts at 0 and go back to 0. From 0 to 2 pi, it complete one cycle. Start from 0 and go back to 0. That means we only choose theta value from 0 to 2 pi. Only pick theta value from 0 to 2 pi. So here we pick theta equal to 0. Here we only use 0 because when theta is 2 pi, we have the same point as theta equal to 0. Now solve the other equation. Theta, cosine theta equal to negative half. Find the reference angle first. When we're solving trigonometry equation, find the reference angle first. For reference angle, we only consider the positive value. Inverse cosine of half. We know that cosine pi over 3 is half, so the reference angle is half. Here, cosine function is negative. We know that cosine function is negative in quadrant 2 and quadrant 3. Cosine function is negative in quadrant 2 and quadrant 3. So when theta belongs to quadrant 2, theta is pi minus the reference angle. Which is 2 pi over 3. When theta is in the third quadrant, since cosine is negative in the second and third quadrant, we must consider both cases. When cosine is in the third quadrant, angle theta is pi plus the reference angle when the angle is in quadrant 3. That's 4 pi over 3. That's all solutions when theta is between 0 and 2 pi. That's all solutions when theta is between 0 and 2 pi. So here we have theta equal to 0, 2 pi over 3, 4 pi over 3. That means for these theta values, the tension line is horizontal. For these 3 theta values, the tension line is horizontal. Next, let's solve this equation here. Sine theta times cosine theta minus 1 times cosine theta times cosine theta. It should be sine theta here. It should be sine theta here. I copy it wrong. 1 minus cosine theta times sine theta. If I distribute sine theta, I have sine theta times cosine theta minus sine theta plus sine theta times cosine theta equal to 0. Combine like terms. Sine theta times cosine theta plus sine theta times cosine theta is 2 sine theta cosine theta minus sine theta equal to 0. Here we can see that sine theta is a common factor. I can pull it outside. If I pull out sine theta, I have 2 cosine theta minus 1. Then solve the equation for theta. Here I can set both of them equal to 0. I set sine theta equal to 0, 2 cosine theta minus 1 equal to 0. When sine theta equal to 0, when the sine function occurs at 0, when y is sine x, sine function equals 0. At 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. On the other sides, negative pi, negative 2 pi, negative 3 pi, and so on. So here theta could be 0, plus minus pi, plus minus 2 pi, and so on. Since we know that When theta from 0 to 2 pi, the curve complete one cycle. So only looking for theta between 0 and 2 pi. We're only looking for theta between 0 and 2 pi, including 0, but not 2 pi. Because at 2 pi, it complete one cycle, it goes back to 0. So only looking for theta from 0 to 2 pi. So for theta between 0 and 2 pi, all we have is theta equal to 0, theta equal to pi. Solve the other equation. 2 cosine theta minus 1 equal to 0. That means cosine theta equal to half. When we solve trigonometry equation, we first of all find the reference angle. Reference angle is inverse cosine of a half. We know that cosine pi over 3 is half. So the reference angle is pi over 3. And cosine function is positive in quadrant 1 and quadrant 4. Cosine function is positive in quadrant 1 and quadrant 4. If theta belongs to quadrant 1, theta is the same as the reference angle, which is pi over 3. If theta belongs to quadrant 4, then theta equal to 2 pi minus the reference angle. If theta is in quadrant 4, theta equal to 2 pi minus the reference angle. So theta equal to 2 pi minus the reference angle. 2 pi minus pi over 3 is 5 pi over 3. So we have 4 solutions here. That means when theta equal to 0, pi over 3, and 5 pi over 3, the tension line is vertical. Now, do we see a problem here? When theta is 0, the tension line cannot be both horizontal and vertical at the same time. When theta is 0, the tension line cannot be both horizontal and vertical at the same time. So here, in order to determine is horizontal or vertical tension at 0, we must take a limit. Take a limit for the slope. Take a limit as theta approach to 0. Here we must take a limit as theta approach to 0. Take a limit for the derivative. As theta approach to 0. We have sine theta times sine theta plus 1 minus cosine theta times cosine theta. Sine theta times cosine theta minus 1 minus cosine theta times sine theta. Take limit for the derivative, we get a slope. If the slope approach to infinity, positive or negative infinity, the tension line is vertical. If the limit approaches to infinity, the tension line is vertical. If the slope approaches to 0, the tension line is horizontal. But if the limit doesn't approach to 0 or plus minus infinity, then it's neither. The tension line is neither horizontal nor vertical. If the limit doesn't approach to 0 or infinity, the tension line is neither horizontal nor vertical. Let's take a limit here. Let's simplify first, then take a limit. If I multiply sine times sine is sine squared theta. Distribute cosine, I get cosine theta plus cosine squared theta minus cosine squared theta. On the denominator, I have sine theta cosine theta minus sine theta plus cosine theta times sine theta. That's the denominator. On the numerator, we have sine squared theta minus cosine squared theta. That can be rewritten as negative cosine square theta minus sine square theta plus cosine theta. On the denominator, sine theta times cosine theta plus itself. It's twice sine theta cosine theta minus sine theta. Then, if I use double angle formula, cosine square theta minus sine square theta is cosine 2 theta plus cosine theta. 2 sine theta times cosine theta is sine 2 theta minus sine theta. Now it's much simpler. If I plug in 0 for theta, on the numerator, cosine 0 is 1. Negative 1 plus 1 is 0. If I plug in 0 to the denominator, sine 0 is 0. The denominator is also 0. We get 0 over 0. In the case of 0 over 0, we can apply L'Hopital's rule. Take derivative to the numerator. Derivative of cosine is negative sine. I get double negative is positive. I get 2 sine 2 theta. If I take derivative for cosine theta, I get negative sine theta. On the denominator, take derivative for sine 2 theta, I get 2 cosine 2 theta. Take derivative for sine theta, I get cosine theta. Then plug in 0 again. If I plug in 0 to the numerator, sine 0 is 0, I get 0. If I plug in 0 to the denominator, cosine 0 is 1, I get 2 minus 1, which is 1. 0 over 1 is 0. That means as theta approaches to 0, the slope is 0. If the slope is 0, the tension line is horizontal. When the slope is 0, tension line is horizontal. If I take a limit, the slope is 0. That means tension line is 0 when theta equal to 0. So when theta equal to 0, the tension line is horizontal. This 0 must be rejected. This 0 must be rejected. That means when theta equal to 0, the tension line is not vertical. When theta equal to 0, the tension line is not vertical. Then plug in the point, plug in theta, find the points. When theta is 0, r equal to 1 minus cosine theta. Cosine 0 is 1, 1 minus 1 is 0. X equal to r cosine theta, y equal to r sine theta. If r is 0, then both x and y are 0. So when theta is 0, the point on the curve is 0, 0. When theta is 0, the point on the curve is 0, 0. When theta is 2 pi over 3, r is 1 minus cosine 2 pi over 3. Cosine 2 pi over 3 terminates in quadrant 2. Cosine function is negative in quadrant 2. Reference angle is pi over 3. Cosine pi over 3 is half. 1 minus negative half is 3 half. Next, we have x equal to r cosine theta, which is 3 over 2 times cosine 2 pi over 3. Cosine 2 pi over 3 is negative half. 3 over 2 times negative half is negative 3 over 4. Y equal to r sine theta. R is 3 over 2. Sine 2 pi over 3. 2 pi over 3 terminates in quadrant 2. Sine function in quadrant 2 is positive. And reference angle is pi over 3. Sine pi over 3 is radical 3 over 2. Sine pi over 3 is radical 3 over 2. If we multiply, we get 3 radical 3 over 4. So the point when theta is 2 pi over 3 is negative 3 over 4, comma 3 radical 3 over 4. That's the point on the curve when theta is 2 pi over 3. Then when theta is 4 pi over 3, r equal to 1 minus cosine of 4 pi over 3. Cosine of 4 pi over 3. Cosine of 4 pi over 3 terminates in quadrant 3. Cosine function is negative in quadrant 3. Reference angle is pi over 3. Cosine pi over 3 is half. 1 minus negative half is 3 over 2. Then x is r cosine theta, which is 3 over 2 times cosine of 4 pi over 3. Cosine of 4 pi over 3 is negative half. Multiply, we get negative 3 over 4. That's an s coordinate. For the y coordinate, y is r sine theta. Y is r sine theta. R is 3 over 2. Sine theta. Theta is 4 pi over 3. 4 pi over 3 terminates in quadrant 3. Sine function in quadrant 3 is negative. And the reference angle for 4 pi over 3 is pi over 3. Sine pi over 3 is radical 3 over 2. Multiply, we get negative 3 radical 3 over 4. So when theta is 4 pi over 3, the point on the curve is negative 3 over 4, comma, negative 3 radical 3 over 4. So horizontal tension line occurs at point 0, 0, negative 3 over 4, 3 radical 4 over 4, and negative 3 over 4, comma, negative 3 radical 3 over 4. At these 3 points, the tension lines are horizontal. Next, for vertical tension line occurs when theta is pi over 3 and 5 pi over 3. 0 is rejected. Vertical tension line occurs when theta is pi over 3 and 5 pi over 3. 0 is rejected. So let's plot in this theta, find the point. The function is r equal to 1 minus cosine theta. Vertical tension occurs when the theta is pi over 3 and 5 pi over 3. When theta is pi, r is 1 minus cosine pi. Cosine pi is negative 1. 1 minus negative 1 is 2. X is r cosine theta, which is 2 times cosine pi. Cosine pi is negative 1. 2 times negative 1 is negative 2. Y equal to r sine theta. Y equal to r sine theta. R is 2. Sine pi is 0. So 2 times 0 is 0. When theta is 0, when theta is pi, the point on the curve is negative 2, comma 0. When theta is pi over 3, r equal to 1 minus cosine pi over 3. Cosine pi over 3 is half. 1 minus half is half. X is r cosine theta. R is half. Theta is pi over 3. Cosine pi over 3 is a half. Half times half is a quarter. For the y coordinate, y is r sine theta. R is half. Half times sine pi over 3. Sine pi over 3 is radical 3 over 4. Sorry, radical 3 over 2. If we multiply together, we get radical 3 over 4. So when theta equals 3, the point on the curve is 1 over 4, comma, radical 3 over 4. Next, when theta equal to 5 pi over 3, r is 1 minus cosine of 5 pi over 3. 5 pi over 3 terminates in quadrant 4. Cosine function is positive in quadrant 4. And reference angle is pi over 3. Cosine pi over 3 is half. 1 minus half is half. S equal to r cosine theta. Here r is half times cosine of 5 pi over 3. Cosine of 5 pi over 3 is half. Half times half is a quarter. Y is r sine theta. So r is half. Theta is 5 pi over 3. So that's half times sine 5 pi over 3. 5 pi over 3 terminates in quadrant 4. Sine function in quadrant 4 is negative. And the reference angle is pi over 3. Sine pi over 3 is radical 3 over 2. Multiply, we get negative radical 3 over 4. So when theta is 5 pi over 3, the point on the curve is 1 over 4, comma, negative radical 3 over 4. So vertical tension line occurs at point negative 2, 0, 1 over 4, comma, radical 3 over 4, and 1 over 4, comma, negative radical 3 over 4. That's the complete solution to this problem. Horizontal tension line occurs at these 3 points. Vertical tension line occurs at these 3 points. That's the complete solution to this problem.